Let's solve the quadratic equation x squared minus 6x plus 13 equals 0 using the quadratic formula and analyze its roots. First, let's identify the coefficients by comparing our equation to the standard form of a quadratic equation, ax squared plus bx plus c equals 0. In our equation, a equals 1, b equals negative 6, and c equals 13. Now, let's recall the quadratic formula. X equals negative b plus, or minus the square root of b squared minus 4 ac, all over 2a. Let's substitute our values into the formula. Plugging in a equals 1, b equals negative 6, and c equals 13, we get x equals negative of negative 6, plus or minus the square root of negative 6 squared minus 4 times 1 times 13, all over 2 times 1. Let's simplify the numerator step by step. First, negative of negative 6 becomes positive 6. Next, negative 6 squared is 36. For times 1 times 13 is 52. Here's where things get interesting. Notice that we have the square root of negative 16. Since we can't take the square root of a negative number in the real number system, this tells us that our equation has complex roots. We can rewrite the square root of negative 16 as 4i, where I is the imaginary unit. Simplifying further, we get x equals 3 plus or minus 2i. This means our equation has two complex conjugate roots, 3 plus 2i and 3 minus 2i. Let's visualize what this means on the complex plane. The complex plane allows us to represent complex numbers, where the horizontal axis represents the real part and the vertical axis represents the imaginary part. The two roots are plotted here, 3 plus 2i and 3 minus 2i. Notice how they're symmetric about the real axis. This is always true for complex conjugate roots of real quadratic equations. In summary, we found that the quadratic equation x squared minus 6x plus 13 equals 0 has two complex conjugate roots. This means the parabola representing this equation never crosses the x-axis in the real number system.